Good day to you. This is Galactic, bringing you the first in the USA series, Unimetrics, Spherical Axiomatization. So space is what? We have a geometry. It's called the linear system of geometry. What is a linear number? Though, are numbers real? Well, of course they're not real. They're relatively real. Now what this means is that we've discovered, finally, the source of the Euclidean system. This is a magnificent accomplishment. It's true evolution also. So I did cover the nature of biological evolution. As we now know, we can close the issue on that subject. There is no such thing. But that does not mean there's no evolution. Humans do evolve. We're there. We made it. The re-basis of the human view of the universe. So we are seeking a re-axiomatization of physical space. The true evolution of humans is in science. In fact, science has found itself in a cul-de-sac. Does that look like a straight line to you? Does that look like a straight line to you? They're curved lines. Well, but it's very important to understand what Einstein accomplished. And why do I bring up Einstein now? Space. It's an axiomatization of space, and it's the first new thing in the geometry of space since Euclid. Newton didn't add anything to that. In fact, Newton had no opinion about space. He didn't give it any characteristics at all. And so he just used straight linear mechanics. Well, Einstein did not. Einstein incorporated into a four-line basis system called spacetime. He incorporated a mathematical structure which captures spherical curvature. And to make that even more pronouncedly different from Euclid, that he used curvature, that really is the secret. Those are spheres, by the way, and I'll be showing you how to use the 3D. I want to just give you an overview of what we're going to do in the next presentation. So I hope you understand that I simply do not accept any of the models because I know where they went wrong. And that's what I'll be showing you. That is an image from Wikipedia on the proton-proton relationship. That is the innermost relationship of two protons. We're going to understand exactly what that means. This is the Bošković force curve. Every single thing on this page is of critical importance. Now in the diagram, I simply have a polar grid because I wanted to show you the radial line, which is adequately portrayed by that polar grid. That represents the force line of Bošković. And there are two of them. The inner circle and the outer circle embrace the universe. So it's the outer edge and the inner edge, which is something that's brand new to science. Science did not know that space has an inner edge, called the spheric infinitesimal. Technically, you cannot see either one of these circles. The outer circle represents the physical edge of the finite universe, beyond the finite limit of what we know of as the universe. There are essentially two universes. This is in fact the source of the parallel universe madness. It's because of an intuited perception. Everyone knows that they should be seeing imaginary space somewhere, but nobody knows where to find it. There are three spaces here. The outer space is infinite space, which is obviously imaginary. We can't see it. It's the edge between finite universal space. We much prefer not to imagine anything, but there's one thing that we're forced to say is imaginary, and that is physical spatial extent going out. You're just going out from anywhere. You're heading towards that infinity. So there has to be an edge. But neither of these circles is imaginary. These circles are geometric circles to conceptualize space, which is in between the two circles. But the inner circle is infinitely small to the proportion that the outer circle is infinitely large. And they have two very slightly different characteristics, but it's balanced on energy and space, where space now must include time. Albert proved that. He used a term time, which is part of a different domain than space. They obviously relate. They relate very similarly to electrical force and magnetic force, which makes electromagnetism. Both of those are separate concepts, but they're never separate from each other. It's a very strange way to say something, and it's actually superpositional. A superposition. A two-component number system for spherical space would be superpositional, as is the complex number system. It's superpositional because it's using numbers to make a higher order number. I don't believe in gobbledygook. I don't believe in equations without explanations. I don't believe in calculus if there's a better way to formulate the universe. And I don't believe in models until you get the basis of your modeling system right. This is the proof sequence for the rebasis of physical science. At the number system level, introducing a new object which replaces the Riemann sphere. It's the preferred basis. That's revolutionary new. This is your professor. My name is Scott Miller. I'll be teaching you the secret of the universe over the next few days.